In his quest to imagine a universe that had always existed, Albert Einstein found himself at odds with his own revolutionary theories. We will follow the evolution of his thinking on the origins of the cosmos, from his renowned cosmological constant to his astonishment upon learning the universe was not static, but actively expanding. This is a journey into the intellect of a man who permanently altered the course of physics, delving into the very moment of creation itself. Have you ever considered what compels a brilliant intellect to pursue the deepest enigmas of existence? Einstein was not merely a physicist. He was a thinker who saw beyond the limits of his era, creating new pathways for comprehending the universe. From his earliest years, he possessed an unquenchable curiosity and a drive to understand the mechanics of the world around him, which ultimately propelled him to devise theories that still inspire awe today. The timeless relevance of Einstein's work is rooted in his remarkable gift for transforming profoundly complex ideas into widely accessible concepts. He achieved this by employing simple analogies and familiar examples, making abstract physics comprehensible to a much larger audience. His theory of relativity, for instance, prompts you to envision time not as a constant, but as a flexible material that can be bent and warped, much like a canvas under immense pressure. It's important to remember that before Einstein, the predominant scientific view of the universe was profoundly different, with most experts believing the cosmos was fixed and unchanging. His discoveries fundamentally challenged that assumption, opening the door for new theories about the dynamic and evolving nature of our universe. His impact on modern cosmology is undeniable, as many principles we now accept as fundamental owe their existence to his audacious vision. Einstein also imparted a crucial lesson, that curiosity is a quality to be nurtured, never stifled. In a world where science can often seem like an impenetrable collection of formulas, he demonstrated that the exploration of the cosmos can be a thrilling adventure filled with fascinating inquiries. Questions like, what if the universe has no end? Or, what exists beyond the reach of our vision? Compel you to look deeper into the fabric of space and time and consider your own place within this immense cosmic puzzle. When you examine his life, it is truly remarkable to consider how such a singular mind could formulate concepts that once bordered on the fantastical. His existence was a voyage of both personal and professional discovery, where each step he took brought him nearer to the truths he so desperately sought. An unwavering passion for the universe and theoretical physics served as the engine for all his work, creating a legacy that continues to fuel the ambitions of scientists and dreamers. Ask yourself this: what change might occur in your life if you started to question everything you observe? Einstein did more than just question his environment. He actively contested the established truths of his time. His life story serves as a powerful reminder that the most extraordinary answers often emerge from the most straightforward questions, and his method of inquiry has applications far beyond the realm of physics. Indeed, the way we now understand time and space has had a profound effect on fields as diverse as philosophy and cosmology. The answer to how one individual could so radically reshape our perception of reality lies in his capacity to view the world through an entirely different lens, a skill that is accessible for any of us to cultivate. His influence is not only contained within his scientific breakthroughs, it is also woven into popular culture, where his very image has become synonymous with genius. From motion pictures to literature, Einstein's name conjures feelings of not just intellect, but profound curiosity and boundless imagination. Reflecting on his life and contributions brings up a vital question. How can you apply his inquisitive mindset to your own experiences? The pursuit of understanding is a lifelong journey, and everyone has the chance to investigate the universe's secrets from their unique vantage point, reminding us that there is always something more to uncover. When you picture Albert Einstein, the iconic image often comes to mind. The untamed hair, the piercing eyes, and a relentless curiosity that guided him to unlock some of the universe's most guarded secrets. However, the story of his dedication to physics and the cosmos doesn't start with intricate equations, but in his childhood home, where inquiry was a fundamental part of life. From his early years, Einstein displayed an uncommon fascination with the universe, sparked at age 5 when his father gave him a simple compass. That small device ignited a curiosity that would last a lifetime, prompting him to wonder why its needle consistently pointed north, regardless of its orientation. This question set him on a path to contemplate the invisible forces that shape our world, a characteristic that would come to define his entire scientific career. As he matured, his thoughts ventured into subjects that many considered excessively abstract, and his teachers often struggled to comprehend his unique methods of reasoning. Instead of adhering to established doctrines, Einstein chose to chart new intellectual territories, asking why anyone should accept something as fact when so much remained undiscovered. This questioning spirit compelled him to master mathematics and physics, the two pillars upon which he would build his legendary accomplishments. His life was marked by significant challenges, and he frequently felt like an outsider in his social and academic settings. Yet each challenge he faced transformed into another opportunity to deepen his understanding of the world. The key to his journey, from a young man feeling out of place to one of history's most pivotal scientists, was his relentless persistence and a profound desire to comprehend the universe. This drive led him to leave his German homeland and pursue new possibilities in Switzerland, where his university studies immersed him in James Clerk Maxwell's electromagnetic theory and Galileo's concepts of relativity, planting the seeds for the revolutionary theories that were to come. How can an inquisitive mind transform abstract questions into something concrete? After finishing his university education, Einstein took a position at the patent office in Bern. While it might have appeared to be a conventional job, this role afforded him the quiet moments needed to contemplate and refine his theories. In his spare time, he delved into concepts that would ultimately reshape our entire comprehension of the universe. The question naturally follows: how did such a seemingly ordinary occupation serve as the launching pad for a revolution in physics? During this time, Einstein began composing papers that fundamentally challenged the established doctrines of his field. His initial major publication on special relativity marked a genuine watershed moment, in which he contended that space and time were far more pliable than anyone had previously imagined. But what makes this insight so critically important? By challenging these fundamental concepts, Einstein unlocked a completely new perspective on the cosmos, as if he had discovered an entirely new lens for viewing reality. His profound curiosity, however, was not confined solely to physics. He was equally captivated by philosophy and the natural world, which served as powerful sources of inspiration for his creative thought. What is the true function of curiosity in the process of discovery? For Einstein, it was the very engine that powered his intellectual drive. Through his inquiries, he not only addressed complex scientific puzzles, but also explored deep philosophical questions that prompted him to consider humanity's position within the immense expanse of the universe. His personal life also left an indelible mark on his scientific pursuits, as his marriage and relationships frequently became intertwined with his cosmic reflections. Each personal obstacle he faced seemed to reflect the very complexity of the universe that so captivated his mind. This prompts us to consider how our own life experiences mold our perception of the world around us. For Einstein, every event, whether positive or negative, became a valuable component in his relentless search for understanding. In many respects, his life was a continuous journey of exploration. As he ventured further into the domain of theoretical physics, his fascination with cosmology intensified. By the end of his life, he had emerged not merely as a brilliant physicist, but as a visionary who completely redefined our place in the cosmos. How is it possible for a single individual to have such a transformative effect on our collective worldview? Throughout his life, Einstein demonstrated that curiosity is indispensable, teaching us that the first step toward genuine discovery is to question what we accept as known. In a world that often insists on definitive answers, his legacy serves as a powerful invitation to never stop exploring and questioning. This constant search for answers in a universe that always holds more secrets is, after all, the very soul of science. Consequently, the life of Albert Einstein stands as a testament to the idea that relentless curiosity and passion are the cornerstones of human advancement. His tale is not merely that of a genius, but of a tireless adventurer who motivates us to gaze at the stars and wonder what lies beyond. Perhaps the most crucial lesson we can take from Einstein is that the universe is a perpetually unfolding enigma, and that our purpose is to keep exploring, dreaming, and above all, learning. The theory of relativity, a concept that completely transformed our knowledge of space and time, remains one of Albert Einstein's most profound legacies. But what is the true meaning of relativity? And why does it hold such significance? To grasp this, you must immerse yourself in the fascinating ideas he left behind. Let's begin by considering speed. When you travel in a vehicle, you perceive the world around you in flux, and if you accelerate, your surroundings blur. But what would occur if you could travel at the speed of light? Einstein shows us that under such conditions, time itself begins to behave in a very peculiar manner. The faster your velocity, the more slowly time elapses for you in comparison to a stationary observer. A notion that sounds like science fiction, but is central to special relativity. Special relativity, which Einstein introduced in 1905, rests upon two core principles. The first is that the laws of physics are identical for every observer, irrespective of their speed. The second is that the speed of light remains constant for all observers, no matter how they are moving. This latter idea directly confronts our everyday intuition. How can something as elemental as light preserve its speed under any and all circumstances? It is here that Einstein starts to reveal a new universe of possibilities. Picture yourself as an astronaut hurtling through space at nearly the speed of light. Looking out of your spacecraft, you would witness the stars appearing to stretch, while time aboard your vessel would pass more slowly. This effect is known as time dilation. If you were to return to Earth after such a long voyage, you would discover that everyone you knew had aged significantly more than you had. This concept is not only captivating, but has also been experimentally verified using high-speed atomic clocks. Then there is General Relativity, which Einstein presented in 1915, and it takes his ideas a step further. In this theory, he proposes that gravity is not a force acting across a distance, but is instead the curvature of spacetime itself. You can visualize space as a vast, flexible sheet. If you set a heavy sphere, like a planet, onto this sheet, it creates a depression. This indentation illustrates how massive objects warp the space that surrounds them. Within this framework, celestial bodies like planets and stars are not simply drifting through empty space. They are actually following the curved pathways created within this fabric of spacetime. The significance of this is that it entirely alters our comprehension of the cosmos. Instead of viewing gravity as a force that pulls objects together, we now understand it as the natural trajectory that objects follow through a warped cosmic landscape, an idea that enabled scientists to predict phenomena like black holes, regions where gravity is so immense that nothing, not even light, can escape. Relativity also explores the notion that time and space are fundamentally interwoven. They are not distinct entities, but are instead components of a single, unified whole. This profound connection has had far-reaching consequences for our modern understanding of the universe. Certain fascinating questions come to mind. What might unfold if a time traveler went back to alter a pivotal moment in history? And what would such an act mean for the very nature of time? While Einstein never explored time travel in the way films do, he gave us the concept that time isn't the straight line we imagine. Instead, he saw it as an intricate weave that can be warped and stretched in ways we are only just beginning to grasp. His theory of relativity has also become the bedrock for many modern innovations, such as the Global Positioning System, or GPS, which must compensate for time dilation to give you precise coordinates. Without relativity, GPS would be functionally useless, dramatically altering the way we navigate our world. It is truly remarkable how a collection of complex equations and abstract ideas has transformed into indispensable tools for our daily activities. Einstein revealed that science is far more than a simple list of established facts. It is a method for investigating the cosmos and our own place within it. The conclusions drawn from his theory of relativity present a new lens through which to view space and time. It pushes you to look past your instincts and embrace the reality that the universe is a much more peculiar and magnificent place than you could possibly fathom. By contemplating these ideas, you can start to appreciate not just the mechanics of the universe, but also your own position within this grand design. Einstein's profound curiosity about the cosmos serves as an invitation for you to pose your own questions and continue the journey of uncovering the secrets of time and space. The universe is an incredible expanse, brimming with wonders and enigmas. Among the most captivating concepts in contemporary cosmology is the notion of cosmic expansion. But what is the true meaning of this? And how did a mind as brilliant as Albert Einstein come to this revolutionary conclusion? Picture the universe as a balloon. As you blow air into it, its surface stretches outward. This very principle is at play in our universe, which has been expanding since it began, pushing galaxies further and further away from one another. So, what initiated this expansion, and what evidence confirms it is actually occurring? The key is found in the work of astronomers and the groundbreaking theories of Einstein. Early in the 20th century, as he was developing his theory of general relativity, Einstein encountered a significant problem. The widely held view at the time was of a static universe, one that was constant and unchanging. Yet the equations governing gravity within his own theory strongly suggested that the universe had to be in motion. The idea of a stable, tranquil cosmos was comforting because it offered a sense of permanence, a feeling that everything had its fixed place. Einstein, along with many of his peers, initially subscribed to the belief in an eternal, unaltered universe. Then, an astronomer by the name of Edwin Hubble made a phenomenal discovery that shifted everything. He observed that not only were galaxies moving away from us, but the speed of their recession increased with their distance. This single observation fundamentally reshaped our perception of the cosmos. If all galaxies are currently speeding apart, it logically follows that in the distant past, they must have been condensed together, possibly originating from a single, infinitesimal point. This realization prompts a deeper question. If space itself is expanding, could time also be more elastic than we assume? This evidence suggests that events across the universe are interconnected in ways we are only now starting to comprehend. Even so, Einstein wasn't immediately persuaded that an expanding cosmos was the definitive answer. In an attempt to stabilize his model and align it with the idea of a static universe, he added a new term to his equations: the cosmological constant. However, this fix turned out to be short-lived. Once the expansion of the universe was observationally confirmed, Einstein famously referred to his cosmological constant as his single greatest blunder, a powerful admission that showcases his humility and unwavering commitment to scientific truth. The expansion of the universe is not just a captivating phenomenon. It also opens up profound questions about its ultimate destiny. If this cosmic expansion continues indefinitely, what will the universe look like billions of years from now? Will galaxies eventually drift so far apart that they become completely invisible to one another? These sorts of questions compel you to contemplate the fate of the cosmos and your own place within it. As our scientific knowledge grows, we've learned that the universe isn't just an empty void, but is teeming with matter and energy that interact in profoundly complex ways. From this deeper understanding, two crucial but mysterious concepts have arisen: dark matter and dark energy. Although dark matter is invisible and cannot be directly detected, its presence is inferred from the gravitational influence it exerts on the things we can see, telling you there is much more to the universe than meets the eye. Dark energy is an even greater puzzle, believed to be the driving force behind the accelerating expansion of the universe. This leaves you to wonder just how much of reality is merely the tip of the iceberg, and how many more secrets the cosmos is waiting to reveal. Reflecting on all of this, it is astounding to consider how Einstein laid the groundwork for these modern inquiries. His relentless curiosity and profound desire to make sense of the cosmos have been a source of inspiration for countless scientists who followed him. It is thanks to his theories that we now have a coherent framework for exploring and comprehending our boundless universe. The expansion of the cosmos and its intricate nature serve as a constant reminder that so much remains to be discovered. Science is a perpetually evolving field, where each new insight brings you one step closer to solving the universe's greatest mysteries, all fueled by the human curiosity exemplified by minds like Einstein's. The notion of an expanding cosmos not only reshapes our understanding of space and time, but also prompts us to ask deeper questions about the nature of existence itself. This ongoing quest for answers, where each new theory gives us a glimpse into the wonder of the universe, reminds you that while our knowledge is substantial, the journey of discovery is an essential part of what it means to be human. For centuries, the concept of a static universe held sway over cosmological thinking. From the ancient Greeks all the way to the early 20th century, a great number of scientists and philosophers were convinced that the universe was an unalterable place, a vast stage for stars and planets that, despite their movements, never changed in their fundamental essence. So, what led Albert Einstein to challenge this deeply entrenched idea, and what findings compelled him to reconsider everything known before? With his brilliant intellect and boundless curiosity, Einstein immersed himself in the study of gravity and the fabric of space. In 1915, his presentation of the theory of General Relativity began to unlock a new comprehension of the cosmos. Yet the idea of a static universe remained fixed in his own mind. He even crafted an equation describing a universe that would neither expand nor contract, because at that time, a cosmos in constant flux seemed almost preposterous. Einstein's adherence to a static universe was not a mere fancy. It was a conclusion drawn from logic and the available observations of his era, which offered no evidence of expansion. Everything changed, however, with the observations of Edwin Hubble in the 1920s. While studying galaxies, Hubble uncovered something astounding. They were all moving away from one another. This could only mean that the universe was not static, but was in a state of dynamic, continuous expansion. This placed Einstein in a difficult position, as he had constructed a mathematical model predicated on a static universe, but was now faced with proof that he was mistaken. How could he align his theories with this new reality? The answer had come in the form of the cosmological constant, a term he added to his equations to permit a static model. Yet, following Hubble's discovery, Einstein conceded his mistake. The very constant he devised as a solution had become a barrier to understanding the universe's true nature. It is helpful to picture the universe as an inflating balloon, where points on its surface drift apart as it grows larger. Einstein originally believed this cosmic balloon was stationary, but he later understood it was actively expanding. This revelation not only changed his own outlook, but also revolutionized modern cosmology, paving the way for entirely new fields of research and exploration. Despite his initial opposition, Einstein eventually accepted that his vision needed to be flexible, demonstrating a core tenet of the scientific method. Science isn't just about being right. It is fundamentally about learning and adapting when presented with new evidence. It is this very capacity for questioning and evolving that makes science such a formidable tool for understanding reality. Einstein's story and his static universe serve as a reminder that even the most exceptional thinkers can be incorrect. His transition to accepting an expanding universe also underscores the human dimension of science, the struggle between intuition and hard evidence. Scientists must frequently abandon deeply held convictions when new information emerges, a process that, while potentially painful, is indispensable for the advancement of knowledge. Einstein's initial resistance to the universe's expansion reflects a challenge we all encounter when asked to let go of our certainties. But what does an expanding universe truly signify for us? It implies that everything you are familiar with, from the farthest galaxies to our very existence, is in perpetual motion. This idea not only defies our perception of the cosmos, but also invites you to reflect on your own life on this vast stage. If the universe is dynamic, shouldn't we be as well? Einstein's paradox and his concept of a static universe are far more than a scientific tale. They reveal that science is a journey of discovery, often full of unexpected detours. They teach us that curiosity and a readiness to ask probing questions are essential for making progress. Despite his eminence, Einstein confronted uncertainty, and in doing so, he left an enduring legacy that continues to inspire generations of scientists and thinkers. In the end, The evolution of Einstein's thinking from a static cosmos to an expanding one offers a powerful lesson on the necessity of intellectual flexibility. Science challenges you to adapt and grow, and this voyage of discovery is unending. Just as the universe continues to expand, so too will our comprehension of it, constantly beckoning us to venture beyond the limits of what is known. As we peer deeper into the vast cosmos, let us remember that every answer gives rise to new questions, and each discovery brings us a step closer to unraveling the mystery of our existence. Have you ever paused to consider how the equation describing our universe is assembled? One of its most compelling elements is the cosmological constant. But what is it? And why was it so vital to Albert Einstein? You can think of the cosmological constant as a clever tweak that Einstein chose to insert into his renowned equations of general relativity, although its actual purpose was far more profound. Visualize yourself inflating a balloon. As you blow air into it, the balloon's surface stretches and expands. If you apply this principle to the universe, you might conclude that everything within it is similarly moving apart. However, Einstein was not entirely convinced that the universe was expanding. In his early years as a scientist, he believed the cosmos was static and eternal. But upon further reflection, he saw that this idea was inconsistent with what the mathematics suggested. The cosmological constant represented his attempt to offset gravity, which pulls everything inward, with a hypothetical force pushing everything outward. It was akin to trying to achieve a perfect equilibrium on a scale. He reasoned that if gravity was exerting a downward pull, something else had to be pushing upward to keep the universe from collapsing under its own weight. But what exactly was this mysterious force? The answer was found in the cosmological constant, which you can conceptualize as a form of vacuum energy, present, even though it remains invisible to us. Einstein theorized that some force must exist within empty space, actively pushing galaxies away from one another. Think of the universe as a vast ocean. The cosmological constant would be the wind driving its waves, preventing all galaxies from being pulled into a central gravitational collapse. Initially, however, the concept of a cosmological constant faced significant resistance. When observational evidence later confirmed that the universe was, in fact, expanding, Einstein felt a sense of embarrassment for ever introducing the idea. He went so far as to label it the single greatest mistake of his career. But the question remains, was it truly an error? As time passed, the cosmological constant found its way back into modern cosmology, particularly with the rise of theories concerning dark energy. Dark energy is the term we use for the enigmatic force that seems to be speeding up the expansion of the cosmos. It is in this context that the cosmological constant makes a dramatic return, with many scientists now viewing it as a primary driver of this acceleration. It's quite remarkable to consider that an idea Einstein himself dismissed as a blunder has since become a cornerstone of how we currently comprehend the universe. Let's visualize the universe as an enormous balloon that is continuously being inflated. While gravity acts as a force attempting to make it shrink, dark energy, embodied by the cosmological constant, provides the outward push that prevents the balloon from collapsing. The delicate equilibrium between these opposing forces is absolutely essential for the stability of the entire cosmos. The implications of this constant are profound. If the energy present in the vacuum is powerful enough, it might propel the universe into a future of infinite expansion. In such a scenario, all galaxies would drift so far apart that each would eventually become a solitary island in a boundless sea of empty space. This is a sobering thought, yet it's also thrilling, because it compels us to contemplate the ultimate fate of everything we know. Over the decades, the cosmological constant has become a subject of intense scientific investigation. As researchers continue their exploration of the universe, their work uncovers more details about this constant's true nature and its specific role in cosmic expansion. The pressing question for many today is whether our current understanding is still in its infancy. With every new discovery, a fresh set of questions emerges, prompting us to wonder if other, yet unidentified forces are also at work in the universe. Ultimately, the cosmological constant teaches us that the cosmos is a realm filled with mysteries, and scientists operate much like detectives, piecing together clues to understand its intricate mechanics. It represents far more than just a figure in an equation. It stands as a testament to the fact that our ideas about the universe are always in a state of flux. It is human curiosity that compels us to keep searching, questioning, and pursuing answers. So you can only imagine what we might learn in the future about this constant and its connection to everything else. The story of the cosmological constant also offers a powerful lesson in humility for all of us, demonstrating that even the most brilliant minds, such as Einstein's, can reconsider their positions as knowledge progresses. So, the next time you gaze up at the star-filled sky, remember that there is so much more than what you can see, and that countless discoveries still await us in our vast and enigmatic universe. When we observe the night sky, a compelling question often comes to mind. How did all of this begin? Pursuing an answer to that question brings us to one of the most transformative theories in all of modern science, the Big Bang. This model, which outlines the origins of the cosmos, has not only reshaped our view of the universe, but has also fundamentally challenged our perceptions of time and space. To understand the Big Bang, you must first appreciate that, at the very beginning, the entire universe existed as an unimaginably small, dense point, known as a singularity. What does that truly imply? Try to picture every atom, every star, and even the vast emptiness between them all compressed into a single point, as if the entire collection of a library were condensed into the pages of one book. Then, in an instant, this point began to expand, and from that expansion, the universe as we know it began to form. So, where does Albert Einstein enter this story? Although his theory of relativity stands as a monumental scientific achievement, he was not the one who originally conceived of the Big Bang. Nevertheless, his foundational work created the intellectual landscape that allowed other scientists to explore the radical idea that the universe is not static, as was once thought, but is in a state of perpetual motion and transformation. One of the most captivating questions that arises from this is, if the universe has been expanding since its birth, what could possibly lie beyond its expanding boundaries? Cosmologists often turn to analogies to help us grasp this concept. Imagine an inflatable balloon. As you blow it up, any marks you've drawn on its surface will spread farther and farther apart. In much the same way, galaxies are moving away from each other as the very fabric of the universe expands, a phenomenon that has been observed and measured. Amid all this cosmic mystery, it's worth clarifying how Einstein is connected to the Big Bang. While he didn't originate the theory, his equations for general relativity provided the mathematical description of how gravity governs the universe's structure. Within these equations, he included his cosmological constant, which he hoped would stabilize his model of a static universe. When it was later proven that the cosmos is actually expanding, he saw this as a failure. Yet this very mistake turned out to be an essential piece of the puzzle for understanding the Big Bang and the ongoing evolution of our dynamic universe. A natural question arises from the Big Bang theory. If this event signified the dawn of time as we understand it, what could have possibly come before? Some scientists propose that our very concept of time is incomplete, and that time itself may have originated in that single moment of cosmic expansion. This idea opens up profound philosophical debates concerning the fundamental nature of both existence and time. A remarkable aspect of the Big Bang is that its legacy remains observable throughout our modern cosmos. The primary evidence for this cosmic birth is the cosmic microwave background, a form of thermal energy also known as relic radiation that permeates the entire universe. You can think of this radiation as the residual heat from the Big Bang, a faint echo, detectable in every corner of space, offering us a whisper from the universe's earliest moments, and enabling scientists to reconstruct its history. Is it not incredible to realize that when you gaze at the night sky, you are witnessing not just stars, but also the ancient remnants of an event from 13.8 billion years ago? The Big Bang model also provides a framework for understanding the emergence of galaxies and large-scale structures. As the universe stretched outwards, gravity's influence caused matter to coalesce, eventually igniting the first stars and forming the earliest galaxies. This brings into focus how gravity, a force you experience constantly, commands such a critical role in cosmic evolution. In its absence, the universe might have remained a formless, chaotic void. Over the decades, researchers have also learned that the universe's expansion is not constant, but is actually accelerating. This discovery points to a compelling concept known as dark energy, the enigmatic force presumed to be driving this rapid expansion. What exactly is this dark energy? While a complete answer still eludes us, we have determined that it constitutes a major portion of the universe and is fundamentally tied to the expansion that the Big Bang initiated. As our exploration of cosmic mysteries deepens, we also confront the puzzle of dark matter, a substance that emits no light and remains invisible to direct observation, yet its gravitational pull powerfully shapes the movement and clustering of galaxies. Together, dark matter and dark energy stand as fundamental components of the cosmic enigma, providing essential clues to how the universe operates on its grandest scales. Investigating the Big Bang is more than a scientific exercise. It is an invitation for you to contemplate your own position within the cosmos. It serves as a reminder that we are all part of an immense universe that has been evolving for billions of years. This awareness inevitably leads us to wonder about the universe's destiny. Will it continue to expand indefinitely, or could gravity one day reverse this process, causing everything to collapse back upon itself? When you reflect on the Big Bang and its far-reaching consequences, it's hard not to feel humbled by the vastness of the cosmos, yet at the same time, feel an intimate connection to it all. The story of the universe is, in essence, our own story, a narrative of creation, expansion, and continuous transformation. The detection of the cosmic microwave background radiation stands as one of the most pivotal discoveries of the 20th century. To truly grasp its significance, imagine yourself in a pitch-black room right as a light is switched on. That fleeting moment fills the darkness with a soft luminescence, revealing what was previously unseen. The cosmic microwave background is analogous to that faint light, illuminating the infant universe and allowing us to look back into its distant past. In 1965, two scientists named Arno Penzias and Robert Wilson were working with a radio telescope in New Jersey when they encountered a persistent, low-level noise in their data. This signal, a constant whisper, seemed to emanate from every direction. Initially believing it to be mere interference, they eventually concluded that they had found the echo of the Big Bang itself, making the cosmic microwave background the first piece of concrete evidence for the universe's explosive origin. This relic radiation helps us understand how the universe has cooled and expanded over eons. If you picture the universe as an inflating balloon, the air inside spreads out uniformly. Similarly, the cosmic microwave background is a remnant of that cosmic expansion. This faint light is observable everywhere we look, and its temperature is a mere 2.7 Kelvin, a cold echo of that primordial fire. Imagine peering through a telescope and seeing not only stars, but the actual history of the cosmos unfolding before you. This is precisely what the cosmic microwave background enables. The radiation itself is primarily composed of microwaves, which may sound unusual, but these waves are like the ambient score of a cosmic symphony, where each note corresponds to a different era in the universe's history. As the cosmos expanded, its initial light and energy cooled, stretching into the microwaves we measure today. The cosmic microwave background also holds subtle patterns that disclose vital information about how matter was distributed in the early universe. Think of it as an ancient map where the contours of mountains and valleys are just faintly visible. This radiation provides a similar map, showing us the initial density variations that acted as seeds for the formation of galaxies and all the cosmic structures we observe today. As researchers delved into the cosmic microwave background, they began to unravel some of the deepest secrets regarding the universe's composition. This ancient radiation led to a startling revelation. The vast majority of the cosmos is made of things you cannot see, namely, dark matter and dark energy. While not components of the radiation itself, their gravitational influence is clearly imprinted on the way this energy is scattered throughout space. The study of the cosmic microwave background also proved essential for validating the cornerstone theories of modern cosmology. An incredible alignment was found between the predictions of the Big Bang model and the actual observations of this relic radiation. This powerful agreement enabled scientists to construct a dependable theoretical framework for charting the entire history and evolution of our universe. However, the picture is far from complete, and many profound questions remain unanswered. For instance, what precisely occurred during the universe's earliest moments, and what chain of events led to the very creation of the radiation you and I can now measure? It seems that every discovery opens the door to new mysteries, with the cosmic microwave background serving as a constant testament to both how far we've come and how much is left to uncover. As you continue this exploration, you find that the cosmic microwave background does more than just recount the universe's story. It prompts you to consider your own place within this grand narrative. You are an integral part of a history that extends across billions of years. By analyzing this radiation, you are granted a chance to forge a deep and meaningful connection with the cosmos, making it more than a simple measurement. It becomes a bridge to our collective origins that invites you to contemplate both the past and the future. So, the next time you look up at the star-filled night sky, remember that you are also sensing an echo of the Big Bang. It is a faint whisper from the dawn of time that reverberates through all of space, continuing to guide our relentless search for knowledge and a greater understanding of everything. Gravity is one of those pervasive and mysterious forces that seems to touch everything. But have you ever stopped to think about how it directs the formation of galaxies and all the grand structures in our vast universe? From an apple dropping from a branch to the clustering of immense galactic superclusters, gravity has the final say in how the cosmos is arranged. But what does that truly imply for the structure of the universe? And for you? To grasp this concept, it helps to envision the universe as an immense canvas upon which galaxies, stars, and planets are painted. In this analogy, gravity is the artist's brush, weaving all of these elements together to create the intricate patterns and structures you observe today. If it weren't for gravity's influence, the universe would be an utterly chaotic realm, with stars adrift and galaxies never coming into existence. The reason gravity functions this way is rooted in its fundamental ability to attract matter. Any object possessing mass exerts a gravitational pull on every other object. In the same way that a heavy bowling ball can influence the path of smaller balls nearby, stars and planets attract other celestial bodies toward them. This is the very mechanism that allows galaxies to remain cohesive, despite the unimaginable distances separating their components. But what occurs when this gravitational dance involves more than just a couple of objects? The interplay between numerous celestial bodies gives rise to an effect known as collective gravity. Picture a crowded party where people are milling about. Some individuals will naturally attract others, forming small groups. This is a simple parallel to how galaxies congregate, as the combined gravitational force between them keeps them bound together in cosmic clusters. When you examine larger and more intricate galaxies, you see that they are far from being just random assortments of stars and material. Within them, gravity also works to concentrate gas and dust into specific regions, which ultimately become the birthplaces of new stars. This entire process functions like a colossal cosmic workshop, where gravity is the force gathering the raw materials needed to forge something entirely new and brilliant. Once these new stars ignite, they become powerful sources of light and heat that dramatically transform their surroundings. The most massive stars unleash intense radiation that can push away the surrounding gas and dust, generating powerful stellar winds. While these winds can disperse material, they can also trigger the collapse of other gas clouds, sparking the formation of yet more stars in a perpetual cycle of cosmic creation and destruction. This brings us to the most massive objects in the universe, black holes, which represent one of gravity's most extreme manifestations. These are regions of spacetime so incredibly dense that nothing, not even light itself, can break free from their grasp. A black hole is born when a massive star runs out of nuclear fuel and its core collapses under its own immense gravitational pressure. But how do these objects impact the galaxies they inhabit? Supermassive black holes, which are found at the hearts of most large galaxies, can profoundly shape the formation and evolution of their galactic hosts. Researchers have discovered a distinct relationship between the mass of a galaxy's central black hole and the total number of stars it contains. This suggests these enigmatic objects might play a pivotal role in regulating the growth and scale of the galaxies themselves. As the universe expands, gravity continues to be a crucial factor in the large-scale distribution of galaxies and structures. While cosmic expansion drives galaxies apart from one another, gravity provides a constant counterforce, pulling them back together. This cosmic tug-of-war is what leads to the formation of the universe's filament and void structure, creating the breathtaking cosmic web you can observe on the largest scales. So, what might these cosmic patterns suggest about the future of the universe? As the cosmos continues its expansion, gravity could face an unprecedented challenge from the mysterious force known as dark energy, which is believed to be accelerating this expansion. This raises the question of whether gravity might one day lose its dominant role in shaping cosmic structures. Scientists are actively investigating how these two opposing forces interact and what their struggle means for the ultimate destiny of the universe. Grasping how gravity orchestrates the formation of galaxies and cosmic structures is not merely captivating. It provides a profound insight into our own position within the universe. You see, every star, galaxy, and black hole belongs to an immense, interconnected web that has been developing for billions of years. Although invisible, gravity is the fundamental force sculpting our cosmos, serving as a constant reminder that we are all part of something immeasurably larger. So, the next time you gaze up at the stars, consider that the very same force holding Earth in its orbit binds each of those distant suns together. Gravity is far more than a simple physical law. It stands as one of the essential keys to unlocking the secrets of our vast and enigmatic universe. As the quest for knowledge presses on, the story of gravity and its cosmic influence is still being written, leaving us to wonder what discoveries the future holds. Have you ever sensed an unseen presence around you? Something you cannot perceive, but that clearly affects everything in your environment. This is precisely the feeling that permeates the scientific community as it grapples with the concepts of dark matter and dark energy. We are certain that dark matter exists, despite our inability to see it, and its impact is absolutely critical to comprehending the mechanics of the universe. Dark matter can be pictured as an invisible shroud that envelops entire galaxies. While our eyes see stars and planets, there is an additional component we cannot directly observe, and scientists calculate that this substance constitutes about 85% of all matter in the cosmos. Its existence is revealed not by light, which it neither emits nor reflects, but through its powerful gravitational pull on the visible matter we can detect. To better understand its role, you can imagine galaxies as grand vessels sailing through a cosmic ocean, with dark matter acting as the very water that buoys them. Without this invisible medium, these galactic structures would simply disintegrate. In essence, dark matter forms the unseen scaffolding of the universe, connecting and supporting galaxies while guiding their motion and evolution. Then there is dark energy, an even more perplexing phenomenon. Picture the universe as a balloon that is not just expanding, but inflating at an ever-increasing rate. While you might assume that the matter inside is driving this growth, there is actually a mysterious force accelerating the expansion from the outside. This force is what we call dark energy, and it is thought to account for roughly 70% of the total energy in the universe. The significance of dark energy becomes clear when you think about an accelerating car. If the engine were to falter, you would expect the vehicle to slow down. However, if some external force continued to push it, the car would keep gaining speed. In much the same way, dark energy is the force compelling the universe to expand much faster than all of our initial models predicted. Scientists began to form these conclusions around the mid-20th century. Observations of remote galaxies revealed something startling. Despite the relentless pull of gravity that should be slowing them down, These galaxies were actually moving away from us faster and faster. This unexpected acceleration pointed to a mysterious driver, and dark energy emerged as the leading explanation for this cosmic puzzle. These concepts are more than just intriguing ideas. They compel us to completely reconsider our knowledge of the universe. If everything we can see is merely a fraction of what truly exists, what other secrets might the cosmos be concealing? It is as if we are only witnessing the tip of an iceberg, with the vast majority lying hidden from view, forcing us to question our entire understanding of reality. The implications are truly profound. If the very structure of the universe depends on dark matter and dark energy, what does this reveal about our own existence? Are we isolated in a largely empty cosmos, or are there imperceptible forces that are fundamentally shaping our reality? This search for answers is pushing us toward new frontiers in both scientific research and philosophical thought. Researchers are actively designing experiments and observations aimed at finally detecting dark matter and uncovering the true nature of dark energy. You could imagine them as explorers navigating a dense, uncharted forest, where each new finding brings us one step closer to solving these great mysteries. Nevertheless, we must acknowledge that definitive answers are still a long way off. It is also crucial to recognize the connection between these phenomena and Albert Einstein's theory of relativity. Einstein revealed that gravity is not a force in the traditional sense, but a curvature in the fabric of space-time. Dark matter directly influences this curvature, while dark energy is intrinsically linked to the expansion of space-time itself, connecting these ideas in ways we are just beginning to grasp. As science advances, so too does our comprehension of the cosmos. Dark matter and dark energy stand as two of the greatest challenges of our time, where each new discovery often generates even more questions, beckoning us to continue our journey of exploration. Ultimately, the study of these concepts inspires us to reflect on our own place within this immense and mysterious universe. Whether we will ever manage to unlock all the secrets the cosmos holds is a question only time can answer. But perhaps the journey toward that knowledge is just as meaningful as the destination itself. What if I told you that Einstein's theories didn't just revolutionize our view of space and time, but continue to be the driving force behind modern cosmology? His theory of relativity, which gave us an entirely new way to perceive the universe, remains the bedrock of our cosmic understanding, and it's incredible to think that ideas from over a century ago are still so relevant today. You can think of relativity as a unique kind of treasure map, one that doesn't just show you a location, but explains the very rules of how you travel through space and time. Without the theory of relativity, our comprehension of cosmic behavior would be akin to sailing a vast ocean without any navigational tools. In this sense, relativity has truly become the instrument that steers us through the universe's greatest enigmas. One of Einstein's most profound gifts to modern cosmology was his insight into connecting concepts that seemed entirely separate. You may wonder how time and space are interconnected, or what specific role gravity plays in this grand scheme. These are central inquiries in cosmology, and because of Einstein, we can now investigate them from an entirely fresh viewpoint. His theory revealed that time is not an unwavering constant. Instead, it can expand or contract based on the velocity of your movement. This insight forces you to contemplate the fundamental nature of time itself. Is it a linear progression, or an endless loop? General Relativity expanded upon this idea by proposing that gravity isn't merely a force but is, in fact, a distortion in the very fabric of spacetime, This groundbreaking concept challenges us to reconsider how gravity influences the most massive objects scattered across the cosmos. To grasp this, you can visualize a stretched trampoline. If you set a heavy ball in its middle, the surface dips and forms a curve. Should you then roll a smaller marble near that indentation, it will naturally curve its path and move towards the larger ball. This is a simple illustration of how gravity functions in the universe, orchestrating an elegant dance among all celestial objects. Relativity, however, is far more than an abstract theory, as scientists have validated many of Einstein's predictions through rigorous experiments and careful observations. For instance, by charting the paths of stars in faraway galaxies, we can witness precisely how gravity bends their trajectories. This naturally prompts an important question for you to consider. How can we be certain that relativity is correct, and not just an elegant intellectual exercise? The proof is found in the theory's remarkable power to forecast the universe's behavior, from the way light bends around immense objects to the measurable slowing of time in the vicinity of a black hole. Every one of these confirmed phenomena serves as a testament to the validity of Einstein's ideas. It truly fills you with a sense of wonder to think that we inhabit a reality where one person's thoughts can so accurately predict the motions of stars and planets. As our understanding of cosmology has matured, it's become evident that relativity is essential for comprehending phenomena such as the expansion of the universe. The very notion that the cosmos is growing was derived, in large part, from Einstein's equations. And without his groundbreaking work, we might still be stuck with a static model of the universe. The observation of redshift in distant galaxies, which shows they are moving away from us, provides the proof for this expansion, and powerfully validates the idea that space itself is stretching. Extending this line of thought, you cannot overlook the impact of relativity on our perception of dark matter and dark energy. These concepts can often feel intangible, yet they are deeply woven into the fabric of Einstein's theories. Relativity offers the essential framework for you to explore how something unseen can exert such a dominant influence on the universe's structure. It is through this lens that scientists develop models explaining how these mysterious elements drive cosmic expansion, effectively illuminating subjects that might otherwise remain completely unknown. Furthermore, relativity serves as the bedrock for emerging scientific theories, including the ongoing search for a unified theory that would merge gravity with the other fundamental forces. Our innate curiosity about the cosmos drives us to investigate complex ideas like string theory and the multiverse, a theoretical collection of all possible universes which are heavily dependent on the principles established by relativity. This makes you wonder if we are on the precipice of even greater discoveries about the universe's true nature. Einstein's effect on modern cosmology is simply undeniable. His work didn't just transform our understanding of the universe, it has motivated entire generations of scientists to continue their own explorations and to never stop questioning. In an era of rapid scientific progress, his ideas continue to serve as a guiding light, illuminating our path toward greater knowledge and providing the foundation for uncovering cosmic mysteries. The quest for answers is ongoing, bringing us ever closer to understanding the immense and magnificent cosmos you and I are part of. Among the most captivating and enigmatic phenomena in the cosmos are black holes. To understand them, you can think of a celestial version of a superpowered vacuum cleaner. Imagine an extremely massive star that has depleted its nuclear fuel and subsequently collapsed under its own immense gravitational force. This collapse is so violent that nothing, not even light, can escape its grasp, which establishes a boundary known as the event horizon. Beyond this point, our current understanding of the laws of physics appears to completely break down. The link between Einstein and black holes is both profound and intricate, as his theory of general relativity actually predicted the existence of these strange objects. He achieved this by redefining gravity not as a force, but as a curvature of spacetime, giving us a new mental model for how mass warps the universe. Just as a bowling ball causes a trampoline to sag, drawing a nearby marble into its dip, a black hole's gravity is so intense that it pulls in everything in its vicinity. Yet, despite being a pioneer of the concept, Einstein himself remained uncertain that black holes could actually exist in reality. Initially, Albert Einstein dismissed the solutions to his own equations that predicted these phenomena, viewing them as nothing more than abstract mathematical quirks. Yet, with the progress of science, researchers uncovered evidence that proved these cosmic objects were real. Just think of the sheer awe astronomers must have felt upon discovering that supermassive black holes reside at the heart of numerous galaxies, our own Milky Way included. And then there is the singularity, the enigmatic core of a black hole. This is a point where density spirals to infinity, causing the established principles of physics to completely unravel. To help you picture it, imagine attempting to crush a whole mountain down to the minuscule scale of a single atom. That is the level of compression we are talking about. As you draw closer to this central point, both space and time begin to act in very peculiar ways. Your experience of time would seem to decelerate, while the gravitational pull intensifies to such an extreme degree that it can warp your very sense of reality. If that notion seems frightening, that's because it truly is. But it is also profoundly fascinating. Despite their capacity for destruction, black holes are absolutely essential for our comprehension of the cosmos. Scientists theorize they are crucial drivers in the birth and development of galaxies, which begs the question, how can something so bizarre and consuming be so indispensable? The solution is connected to the immense energy they eject, such as the powerful jets of X-rays produced by matter being pulled into them. This leads to a compelling thought. What would it feel like to get close to a black hole? Should you find yourself in such a position, whether by fortune or misfortune, you would undergo a process known as spaghettification. This peculiar name captures how immense gravitational forces would simultaneously stretch and squeeze you, transforming your body into a long, thin strand. It's a difficult concept to grasp, but it illustrates the sheer power at play. It's important to realize that black holes are not solitary oddities. They function as integral components of a larger cosmic web. It's thought that the universe contains a greater number of black holes than it does stars. Can you conceive of a cosmos filled with these entities, each one steadily devouring matter and growing in size, thereby perpetuating a continuous cycle of annihilation and rebirth? Contemporary science has progressed to where we can now indirectly witness these phenomena. A landmark moment occurred in 2019, when the very first image of a black hole, located in the Messier 87 galaxy, was successfully captured. Just imagine the elation of the scientists involved. For them, viewing that image was like seeing a long-held legend materialize into reality, providing stunning visual proof of Einstein's theoretical work. Nevertheless, a vast amount of information is still waiting to be uncovered. Profound questions, like what exists past the event horizon, or if escape from a black hole is even conceivable, are still without answers. Some hypotheses propose the existence of space-time conduits, commonly called wormholes, that could link disparate regions of the universe. The debate continues whether these are purely fictional concepts or if they hold a basis in reality. With every technological leap, our telescopes and satellites collect an ever-increasing volume of data, enabling us to probe more deeply into these celestial puzzles. The unquenchable nature of human curiosity and our drive to comprehend the unknown compel us to constantly investigate and challenge our assumptions. What extraordinary discoveries about black holes and their universal significance might the future hold for us? Therefore, the next time you consider black holes, recall that they are far more than simple cosmic devourers. They are critical components in the grand puzzle of the universe. They serve as a powerful reminder of our limited understanding and simultaneously highlight humanity's capacity to solve the most profound enigmas through sheer ingenuity and curiosity. The intricate nature of black holes beckons us to peer beyond our own world into the immense and mysterious expanse of the cosmos. Among the most captivating and intricate concepts in contemporary physics is string theory. To grasp its significance, you must first remember that our universe is fundamentally composed of minuscule particles in constant interaction. The problem is that conventional particle models have hit a roadblock in the quest for a single, unified framework that can account for all of nature's fundamental forces. And it is at this very juncture that string theory makes its entrance. Picture every basic particle, not as a dimensionless point, but as a vibrating filament of energy, much like the string of a guitar. Different vibrational patterns of these strings give rise to different types of particles, in the same way that varying the vibration on a guitar string creates distinct musical notes. It is a staggering idea to think that all matter and energy in existence could simply be the product of these infinitesimally small oscillating filaments. While string theory may initially sound like something out of science fiction, its true appeal lies in its potential to harmonize Einstein's theory of relativity with the principles of quantum mechanics. Ever since Einstein developed his revolutionary ideas, physicists have grappled with the challenge of creating a single model that integrates gravity with the nuclear and electromagnetic forces. String theory might just be the breakthrough needed to weave all these threads of physics into a single, cohesive tapestry. So, what is the connection to Einstein and his legacy? By focusing on the geometry of spacetime, Einstein showed us that gravity is essentially the warping of space. String theory expands on this notion by proposing that space possesses more dimensions than our senses can detect. Although we experience a world of 3 spatial dimensions plus time, this theory posits that other dimensions exist, possibly compacted and hidden from our everyday perception. Can you wrap your head around the idea of a universe with dimensions beyond our direct experience? This concept of additional dimensions is not only captivating, but also prompts a series of profound questions. If these other dimensions are real, what are their implications for how we understand the cosmos? It is possible that they hold the very answers to phenomena that currently baffle our scientific models, from the nature of gravity to the flow of time itself. Perhaps most compelling of all is the notion that string theory's scope extends beyond just defining particles. It aims to provide a comprehensive explanation for the way every force throughout the entire universe interacts with one another, offering a potential theory of everything. In many ways, string theory positions itself as a potential theory of everything, aiming to unite all the forces of nature. The challenge, however, is confirming its accuracy. This is far from straightforward. as the immense energy levels where these supposed strings vibrate make it nearly impossible to design experiments capable of detecting them directly. This creates a significant scientific puzzle. How can you validate a theory if its core components are beyond your ability to observe? To solve this, scientists are turning to ingenuity and innovation. They are devising indirect methods to test string theory, such as hunting for supersymmetric particles, which are a direct prediction of the framework. Just imagine the thrill of discovering a new particle that validates decades of theoretical work. Yet, the significance of string theory extends well beyond intellectual exercises in physics. It carries profound consequences for how you comprehend the nature of reality itself. If the universe is fundamentally composed of vibrating strands of energy instead of distinct points of matter, then your perception of the world is far more intricate and interconnected than previously thought. This inevitably leads you to contemplate your own existence and your position within this immense cosmic web. Of course, like any groundbreaking concept, string theory has its share of skeptics. Some in the scientific community contend that it is overly speculative and lacks the support of concrete empirical evidence. Nevertheless, the sheer elegance of its mathematical structure and its power to unify apparently unrelated physical concepts continue to draw many researchers to investigate its possibilities. It serves as a reminder that in science, the most transformative breakthroughs often begin with imagination. As you continue to probe the mysteries of the universe, string theory encourages you to think on a grander scale and challenge your established knowledge. It compels you to accept that your current grasp of physics might represent just a fraction of the total picture. You are left to wonder what other truths the cosmos might hold if you find the courage to venture beyond the familiar. The notion of the multiverse has long captivated the minds of scientists and philosophers alike. But what does it truly entail? The proposition that your own universe is just one among countless others is both exhilarating and deeply perplexing. You can visualize it as a cosmic ocean teeming with bubbles, where each bubble is a separate universe governed by its own unique set of physical laws and fundamental realities. But what led scientists to even formulate such an idea? While Albert Einstein did not directly propose the multiverse, his revolutionary work provided the essential foundation for others to develop the concept. His theories of relativity demonstrated that spacetime is not a rigid stage but a dynamic fabric, which opened the door to considering multiple forms of reality. If space and time can stretch and curve, it raises the question of why other universes with entirely different properties couldn't exist. Think about the implications of parallel universes for a moment. Could there be another reality where you chose a different path at a pivotal point in your life? Or perhaps one where the dinosaurs never faced extinction, and another where human technology failed to emerge? While these scenarios may sound like something from a novel, some scientists are seriously investigating the mechanisms that could make them possible. This is where string theory, a popular framework among today's theoretical physicists, re-enters the conversation. It proposes that fundamental particles are not dimensionless points, but tiny vibrating strings. The theory requires these strings to exist in multiple dimensions, suggesting a reality far more extensive than the one you can perceive. These additional dimensions make the multiverse concept feel more concrete and scientifically grounded, prompting you to ask what other realities might arise from different modes of string vibration. What is particularly fascinating is that if other universes do exist, they might each possess different fundamental constants of nature. How would a universe function if the force of gravity was significantly weaker or stronger? Or if the speed of light was altered? This line of inquiry leads to a crucial question about your own existence. Why does your universe have the precise properties that it does? The multiverse offers a possible answer: that your cosmos is simply one of the many where the conditions happened to be perfect for life to arise. Some researchers, such as the cosmologist Max Tegmark, have even developed classifications for different types of multiverses. Tegmark's framework outlines universes that might be very similar to your own, with only slight differences, as well as radically different ones, where the known laws of physics are completely irrelevant. While still highly speculative, this systematic approach provides a way to organize the various ideas about a potential multiverse. The idea of a multiverse also brings with it profound philosophical dilemmas. As a conscious being, what does it mean to learn that you may be just one part of an endless tapestry of universes? Such a realization could feel incredibly freeing, or it could make your existence seem utterly insignificant. The confirmation of other universes would undoubtedly reshape your understanding of life, meaning, and purpose. However, the multiverse hypothesis is not without its detractors. A significant number of scientists point out that the idea is exceptionally difficult, if not impossible, to either prove or disprove, which places it on the boundary between empirical science and pure philosophy. After all, if another universe is completely separate from your own, what method could you possibly use to begin studying it? This remains a central challenge that proponents of the theory must confront. Despite these scientific hurdles, the multiverse has become a powerful source of inspiration for countless works of literature, film, and art. Popular movies and television shows frequently explore the themes of alternative realities and parallel worlds, which has helped make the concept much more familiar to a broader audience. In doing so, it renders a complex and often distant scientific topic more relatable and engaging for everyone. In this larger discussion, Albert Einstein's work continues to be fundamentally important. His willingness to completely overturn conventional ideas about space and time is what cleared the path for later generations to entertain radical concepts like the multiverse. So, even though Einstein himself never put forward a theory of other universes, his intellectual legacy is what empowers scientists today to continue exploring these mind-bending possibilities. Ultimately, contemplating the multiverse pushes you to question your entire understanding of the cosmos and reflect on your place within a potentially infinite landscape of different realities. It forces you to ask whether you are truly alone in your experience of existence, or if you are instead an integral part of something far larger and more complex than you can ever imagine. Our continued questioning of the universe leads us to concepts like the multiverse, which serves as a powerful reminder that human curiosity is boundless. Every new theory and breakthrough edges us closer to grasping the true scale of our surroundings, revealing a journey of discovery where each answer simply uncovers more profound questions. The possibility that our universe is just one among many presents an exciting new frontier for exploration, underscoring how science guides us into the unknown. So, what knowledge unlocked our ability to comprehend the sheer vastness of the cosmos? The answer to that question is found primarily within the theories of Albert Einstein. His revolutionary ideas have been consistently validated over the decades by numerous experiments, solidifying his place as a titan of modern science. The story of how these theories were confirmed in the realm of cosmology is both intricate and captivating. One of the most pivotal experiments that affirmed Einstein's work occurred during the solar eclipse of 1917. On that occasion, British astronomers positioned themselves at strategic global locations to witness how starlight bends as it traverses the sun's gravitational field. This very phenomenon, which Einstein had forecasted in his theory of general relativity, showed that gravity warps not just matter, but light itself, and its confirmation launched him into worldwide renown. Then there is the matter of the universe's expansion. In 1929, the astronomer Edwin Hubble, using a telescope on Mount Wilson, made a groundbreaking observation of distant galaxies. By examining the light they emitted, he deduced that these galaxies were all receding from us, providing clear evidence that the universe is expanding. This discovery was a direct endorsement of Einstein's concepts of a dynamic cosmos and powerfully substantiated his work. The cosmological constant is another fascinating component of this story. Einstein originally added this term to his equations to accommodate the prevailing scientific belief in a static universe. Yet, following Hubble's discovery, he famously disavowed the constant, labeling it his single greatest blunder. In a remarkable turn of events, however, this very constant has become essential to modern cosmology, especially for explaining the universe's accelerating expansion. How could an idea once dismissed as an error now be so central to our understanding? Evidence for this acceleration came from supernova observations. In 1998, two separate teams of astronomers, one in the United States and the other in Australia, noticed that distant supernovae were dimmer than their models predicted. This observation led to the startling conclusion that the universe's expansion is not only ongoing, but is also speeding up, providing strong support for the existence of dark energy. Black holes offer another compelling domain where Einstein's predictions have been verified. The existence of these enigmatic cosmic objects was a direct consequence of his theory of general relativity, and today we can directly observe their effects. The monumental event of 2019, when we captured the first-ever image of the black hole at the heart of the Messier 87 galaxy, allowed us to see with our own eyes what Einstein had only imagined over a century prior. Furthermore, experiments focused on gravitational waves, the faint ripples in spacetime generated by colossal cosmic events, have also provided confirmation of Einstein's theory. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, collaboration achieved the first direct detection of these waves, a phenomenon Einstein had predicted long ago. This discovery has launched a new era in astronomy, enabling you to perceive the universe in ways that were previously impossible. Even particle physics, through experiments at facilities like the Large Hadron Collider, or LHC, contributes to validating Einstein's theories. As scientists investigate the fundamental particles that constitute our reality, they uncover evidence that reinforces the idea of gravity as one of the universe's most primary forces, just as Einstein proposed. It's remarkable how the quest for the infinitesimally small has corroborated the vision of a man who thought on the grandest possible scale. What's perhaps even more astounding is the way Einstein's concepts have permeated our modern technology. From the satellite navigation systems that guide you daily to advancements in medical imaging, the theories of relativity have a tangible effect on our lives. The accuracy of the location services on your phone, for instance, is critically dependent on applying the principles of relativity. Without Einstein, our technological landscape would be fundamentally different. Finally, the interplay between quantum theory and relativity has been a fertile ground for experimental physics, Despite Einstein's personal reservations about quantum mechanics, his work laid the essential groundwork for its development. Modern investigations into phenomena like quantum entanglement, where particles remain interconnected across vast distances, demonstrate how his theories continue to be deeply relevant and profoundly inspiring to this day. As you can see from these experiments, Einstein's work has not just been repeatedly confirmed. It has also sparked entirely new lines of inquiry and led to countless discoveries. The way his theories have guided us toward a more profound comprehension of the universe stands as a testament to his unparalleled genius. One can only wonder what other cosmic secrets are waiting to be revealed by inquisitive minds bold enough to challenge everything we think we know. His insights have shaped every facet of contemporary cosmology, from the way light bends around massive objects to our understanding of cosmic expansion. As our exploration of the universe deepens, Albert Einstein's theories remain the essential compass for our pursuit of knowledge, pointing toward secrets we have not yet uncovered. It makes you wonder what incredible discoveries are still waiting for us over the horizon. Picture a reality where profound concepts about the cosmos are not confined to academic settings, but are woven into movies, music, and literature. With his famously untamed hair and intense eyes, Albert Einstein became more than a groundbreaking physicist. He transformed into an enduring cultural figure. The question is, how did he achieve such a timeless status? The theory of relativity, a concept that fundamentally altered our perception of space and time, served as a catalyst for artists, authors, and directors to creatively explore abstract ideas in more approachable forms. You've likely seen his image portrayed in numerous ways on screen, from animated caricatures to central figures in historical films. His very name seems to spark a blend of wonder and reverence. So, what is the source of his image's immense power? It could be his unique talent for merging the intricate nature of science with the fundamental simplicity of human curiosity. Ultimately, we all share a deep-seated desire to comprehend our position in the cosmos, and Einstein provided us with the intellectual framework to begin that journey. Have you ever considered the claim that Einstein was the one who ignited modern science? His celebrated equation, E=mc², is far more than a mere formula. It stands as a powerful symbol of the profound relationship between energy and matter. The idea was so revolutionary that it reshaped our view of energy in daily life, influencing everything from the power in our homes to the principles of nuclear reactions. It's truly remarkable to consider how one concise equation could lead to such far-reaching implications. You can find his concepts adopted by popular culture in some very surprising places. For instance, the television show The Simpsons often delves into scientific principles, and one particular episode offers a comedic take on relativity. This approach not only makes complex science more approachable for a wider audience, but also demonstrates how his intellectual heritage continues to thrive in our collective awareness, proving that science can indeed be entertaining. Let's shift our focus to the world of music, where artists such as David Bowie incorporated references to relativity into their lyrics, merging science and art with profound effect. His song, Space Oddity, for instance, explores themes of cosmic discovery that echo the very subjects of Einstein's life's work. The way these two fields can intersect so powerfully stems from the universal human quest for meaning, a pursuit that unites us all through time. Of course, Einstein's interaction with popular culture wasn't always seamless, as his theories were frequently misconstrued or overly simplified. This brings up a fascinating dilemma. Is it more beneficial to distill a complex idea for mass comprehension, or should its full intricacy be maintained, even if it means some people won't grasp it? Einstein himself championed scientific clarity, yet he was keenly aware that true depth is often sacrificed in simplification. His impact on the field of education is equally significant, with his image frequently used to motivate aspiring young scientists. In many educational settings, he is portrayed not just as an unparalleled genius, but also as an individual who faced personal struggles and self-doubt. This approach helps to humanize the scientific endeavor, making it feel more attainable for everyone, and teaching us that persistence and curiosity are just as crucial as intellect. Furthermore, Einstein's widespread fame gave rise to an interesting trend: the commercialization of his name and likeness. His face now appears on everything from T-shirts to coffee cups, serving as a popular emblem of intelligence and ingenuity. This begs the question of whether this is a genuine homage to his legacy, or merely an effort to profit from his renown. The truth is likely found in the intricate nature of our modern culture, where scientific icons and commercial interests frequently overlap. In the literary world, his life and theories have been examined in numerous biographies and novels, which aim not only to explain his scientific contributions but also to uncover the person behind the legend. This literary fascination is also mirrored in philosophy, where his work has had a profound impact. Modern thinkers continue to debate the consequences of his theories on our very definition of reality, especially how relativity reshapes our perception of time and space, fueling a rich dialogue that continually pushes the boundaries of our understanding. The power of Einstein's persona was so great that it even spurred social movements, as his advocacy for peace and human rights has echoed through the decades. This transformed him into an icon of social justice, as well as a scientific pioneer. The way a scientist can become an agent of social change is rooted in a core conviction, like his, that knowledge must always be applied for the betterment of all humanity. Yet his legacy is not without its detractors, and over the years his theories and even his personal life have been the subject of considerable debate. Challenges have been raised regarding specific elements of his work, which in turn prompts us to consider the very essence of the scientific method. It forces us to ask whether science provides absolute certainty, or is, in fact, a perpetually unfolding process of inquiry. Within the realm of social media, Einstein's presence has seen a powerful resurgence. You can see memes, quotes, and short videos about his life and ideas being shared every day, which confirms his lasting relevance. This persistence in the digital era suggests that even with all our technological progress, the fundamental questions about the cosmos and our place within it are as compelling as ever. The allure of Albert Einstein stems not just from his monumental scientific breakthroughs, but also from the controversies and critiques that shadowed him during his lifetime. What was it that so profoundly unsettled some of his peers, and why did his revolutionary ideas ignite such fierce debate within the scientific establishment? We are about to explore the fascinating landscape of criticism and contradiction surrounding this genius, revealing that even a figure of his stature was never beyond reproach. During his era, the scientific consensus held that the universe was unchanging and had existed forever. To align his own theories with this established view, Einstein introduced what he called the cosmological constant. Yet, upon the discovery that the universe is in fact expanding, he famously declared this very constant to be his greatest mistake, a reversal that carried profound implications. This cosmological constant came to represent Einstein's struggle against new concepts. Certain colleagues viewed it as proof that he was clinging to outdated beliefs, unable to embrace change. You might wonder if a fear of the unknown drove him to protect a vision of the cosmos that had already been superseded by new evidence. His resistance was also apparent in his views on quantum mechanics, one of the most transformative theories of his time. Einstein voiced his profound skepticism with the famous statement, "God does not play dice." This single phrase encapsulates his belief in an orderly, predictable universe, which stood in direct contrast to the probabilistic reality described by quantum mechanics. Many of his peers, most notably Niels Bohr, championed the new theory, sparking intense arguments that have since become legendary in the annals of science. This begs the question of why Einstein felt such profound discomfort with this revolutionary way of understanding the world. His intellectual friction with fellow scientists, however, extended beyond just the quantum realm. His refusal to accept certain consequences of his own theory of general relativity, such as black holes, ignited further controversy. Even though his equations predicted these cosmic phenomena, he hesitated to acknowledge them as real, leading this legendary physicist to question the fruits of his own genius. Some detractors claimed his traditional mindset in physics became a constraint on his vision. Could it be that his extraordinary intellect also left him susceptible to overanalyzing and resisting new conclusions? This internal conflict is a key reason his legacy remains so multifaceted. You see him celebrated as the architect of relativity, yet simultaneously critiqued for his failure to fully welcome the next wave of scientific revolution. By the 1930s, his opposition to quantum mechanics was so intense that some labeled him a scientist looking backward, not forward. Nevertheless, you could also interpret his resistance as a steadfast defense of intellectual discipline and scientific rigor. This makes one wonder if his battle against emerging theories cast him as a hero or a villain in the story of science, as compelling arguments exist for both interpretations. Beyond his scientific work, Einstein's private life was filled with contradictions and came under intense public scrutiny as his romantic relationships and family choices drew criticism. The dilemma between his professional dedication and his personal responsibilities fueled discussions about his priorities, posing a question that still resonates today. Can one be a monumental genius and also a devoted partner or parent? The way people viewed Einstein was also heavily influenced by the historical era he inhabited. With the First and Second World Wars as a backdrop, his concepts were constantly re-examined through the lens of contemporary needs and global anxieties. In more recent times, new breakthroughs in physics have led to a re-evaluation of some of the criticisms aimed at Einstein. For instance, the cosmological constant he once dismissed has made a comeback as a leading candidate to explain dark energy. It's fascinating to consider that history may have vindicated him on points he himself couldn't embrace, showcasing how such controversies often reveal as much about the evolving nature of science as they do about an individual's character. This raises a fundamental question about what it takes to be on the cutting edge of human knowledge. It frequently requires you to challenge the existing framework and have the fortitude to endure criticism. In that respect, Einstein was an authentic trailblazer, yet he was also a product of his era, trapped between a powerful drive to advance and the human need for acceptance. Ultimately, his life story is a tapestry woven with intricate nuances and deep contradictions. The critiques of his work and his reluctance to adopt certain shifts in thinking do not detract from his genius. Instead, They add layers of depth to it. They serve as a powerful reminder that the scientific journey is fraught with uncertainty, where even the most brilliant minds grapple with doubt. While only time will reveal the ultimate shape of his legacy, his life remains a profound chronicle of our collective quest to comprehend the cosmos. So, what kind of inheritance is left by someone who fundamentally questioned the established laws of physics? With his luminous intellect and boundless curiosity, Albert Einstein left a permanent impression on science, which in turn reshaped the world you live in. The full extent of his influence on contemporary physics and our cosmic awareness is complex, yet its evidence can be found in virtually every field of modern science. Einstein's creative genius provided the bedrock for a significant portion of today's physics. His theory of relativity did more than just transform our perception of space and time. It also established the very foundation for modern cosmology. You might ask why his legacy holds such immense importance, and the answer is found in the way his concepts have extended far beyond theoretical physics to impact the practicalities of everyday existence. Just think about the technologies that have emerged directly from his theories, ranging from the precise timing of GPS networks to our fundamental grasp of nuclear power. His impact is woven into the fabric of your daily routine, and it's hard to envision our modern world without these advancements. Far from being a mere abstract idea, relativity has tangible applications that have completely reshaped how you interact with your surroundings. Furthermore, Einstein's work unlocked a new realm of inquiry, prompting us to ask what lies beyond the current horizon of our knowledge. His contributions didn't just offer solutions, they also created entirely new puzzles to solve. The field of quantum physics, which grew from questions he was instrumental in asking, has spurred incredible progress in computing and technology, heralding a future ripe with potential. The real question for you, however, is whether we are fully prepared to face the implications of these ongoing discoveries. Beyond the walls of laboratories and academic halls, Albert Einstein's cultural footprint is immense. His very image, with its famously untamed hair and thoughtful expression, has come to define our archetype of a genius. This begs the question, what does it truly mean to be a brilliant mind in today's world? His life and theories have fueled the ambitions of countless scientists, artists, and philosophers, serving as a powerful reminder that curiosity and creativity are the very engines of human advancement. Despite his towering stature, Einstein's career was not without its share of friction and debate. He encountered significant criticism and faced professional challenges, even from his peers. Some of his groundbreaking theories were met with skepticism, and his persistent reluctance to fully embrace quantum mechanics makes him a particularly compelling figure in the annals of science. Does this suggest that the most revolutionary thinkers are also the most contentious? Einstein's story certainly makes a strong case for this idea, and it is a vital part of his enduring legacy. Discussions of his work are not confined to the domain of physics. Philosophy has also been deeply shaped by his concepts. When you contemplate the nature of space and time, you are confronted with profound questions about existence, the fabric of reality, and our own position within the cosmos. What is the true significance of living within a universe that is continuously expanding? Einstein's work urges you to consider these questions, challenging you to peer beyond the obvious. His legacy is also profoundly felt in the field of education. The narrative of Einstein's life, marked by early struggles, ultimate triumphs, and an unyielding quest for knowledge, serves as a constant source of motivation for students and educators. It illustrates that science is not merely a collection of facts and equations, but a deeply human journey of discovery and comprehension. The key takeaway from his approach to learning is that imagination, curiosity, and perseverance are just as crucial as sheer intellect. Ultimately, Albert Einstein's legacy is a testament to the idea that the search for knowledge is an infinite journey. His concepts continue to redefine our understanding of the universe, compelling us to ask new questions, to venture into the unknown, and to dream of what might be possible. As you stand on the shoulders of this giant, you are reminded that the cosmos is filled with endless mysteries, and that the very act of seeking answers is what defines our humanity. The principles Albert Einstein laid down are now fundamental components of curricula in schools and universities worldwide, influencing how the next generation perceives the sciences. In the classroom, however, students are not just memorizing his formulas and theories. They are being taught to engage in critical thought, to challenge assumptions, and to explore new possibilities. This may be one of Einstein's most important contributions, the power to inspire others to find their own answers. Einstein's influence transcends physics, reshaping how you might even view life itself. His celebrated declaration, "Imagination is more important than knowledge," underscores that creativity is a formidable catalyst for change. Just think of how many transformative ideas have been born from a single spark of imagination. Einstein demonstrates that while knowledge is indispensable, it represents only the beginning of the journey, not the destination. Over the decades, his name has become synonymous with the relentless pursuit of understanding. As you confront global issues like climate change and the energy crisis, his scientific frameworks offer invaluable tools for developing solutions. Is it possible to devise new answers inspired by his way of thinking? The solution may very well depend on how effectively we can adapt his legacy to the challenges of the modern era. Reflecting on the life and work of Albert Einstein, it becomes evident that his impact is truly multifaceted. He did more than just revolutionize physics. He left an indelible mark on culture, philosophy, and education. His legacy is an ongoing invitation for you to keep exploring, to keep questioning, and to never cease in the pursuit of learning. In the end, isn't that what we are all searching for? A more profound understanding of ourselves and the universe we call home. So, as you gaze up at the star-filled sky each night, remember that every single star is a monument to Einstein's work, and to all those who have followed in his footsteps. His legacy is a call to action, to investigate the unknown, to challenge established truths, and to continue the quest for answers in a cosmos brimming with mysteries. The universe itself is a vast ocean of enigmas, prompting an exhilarating question as you look to the heavens. What does it really mean to exist in a place of such immense scale and complexity? In our effort to comprehend our role in this cosmic drama, we face deep reflections that have fascinated thinkers for centuries. Albert Einstein, with his revolutionary perspective on space and time, has left us a heritage that goes far beyond mathematical equations, inviting us to contemplate our own place in the grand design of the universe. One of the greatest questions that echoes in the human psyche is whether we are simply a product of cosmic chance. It is easy to feel like a tiny island in an infinite sea of existence. However, could it be that each of us holds a more significant purpose in the universal order? Through Einstein's theories, science provides a viewpoint that challenges our ordinary perception of reality. Instead of seeing ourselves as passive observers, you can begin to recognize your role as an essential part of an interconnected whole. The notion that the universe is in a state of constant flux and evolution raises another captivating question. What is the true nature of time? Einstein revealed to us that time is not a straight, unyielding line, but an experience that is deeply personal and subjective. This realization prompts you to reflect on how you lead your own life. If time itself can bend and stretch, shouldn't you strive to make every single moment count? The idea of time as a flexible dimension implies that each instant is both unique and extraordinarily precious. As you delve into the nature of your existence, you also discover that the universe is teeming with wonders and intricate complexities. What lies behind the simple beauty of a star shining brightly in the night sky? Every star is a reminder that even though we are minuscule in comparison to the cosmos, our lives are intrinsically linked to the history of everything that surrounds us. The light from those stars has journeyed for thousands of years just to reach your eyes, proving that, in a profound way, you are a part of their story. Considering the sheer vastness of the universe also brings up the question of cosmic solitude. Are you truly alone in this immense expanse? The search for life beyond our world has been a persistent theme in both science and philosophy. Although Einstein did not tackle this question directly, his work has always encouraged us to look toward the stars not with certainty, but with an insatiable curiosity. Considering the potential for other intelligent life in the cosmos encourages you to contemplate the essence of being and the universal ties that bind us all. In this pursuit of understanding, science and philosophy become inseparable guides. Albert Einstein demonstrated that what you perceive with your senses may only be a glimpse of a more profound truth, showing how your own experiences and viewpoints construct your reality. This realization leads to a fundamental question. How can you broaden your understanding and remain open to new concepts and possibilities? Throughout this journey of discovery, the matter of your personal existence comes sharply into focus. What does it mean to be you in a universe of such immense scale? Each person has a singular history, a collection of experiences that has forged their identity, and physics confirms that you are literally made of stardust, carrying the story of the cosmos within you. Meditating on your existence helps you appreciate both your distinctiveness and your deep connection to the cosmos. As you explore the nature of the universe, you also encounter the fundamental concepts of time and space, and their impact on your daily life. While time can feel like a relentless force in our fast-paced world, Einstein taught us to see it as a grand dance we all take part in. Every moment of happiness, sorrow, love, and loss is simply a movement in this cosmic choreography that unites everyone. The interconnectedness of everything prompts you to consider how your actions influence the world. What kind of legacy will you leave behind in the universe? Every single action, no matter how minor, has the potential to alter reality. The way you treat others, care for the planet, and pursue knowledge all create ripples across the vast fabric of existence. This quest for meaning also forces you to confront the concept of death. What truly happens when you depart from this world? Although science lacks all the answers, being curious about what lies beyond can inspire you to live with a greater sense of purpose. Perhaps death is not a conclusion, but a transition, a step into the unknown that offers a chance to become part of something immeasurably larger. The universe, with its endless wonders and mysteries, also teaches a profound lesson in humility. Gazing up at a star-filled sky, it is easy to feel small and insignificant. Yet, it is crucial to remember that each person is a spark of the universe's own expanding consciousness. Facing this immensity with humility can inspire you to act with greater compassion and empathy toward others. Ultimately, when you reflect on the cosmos and your own existence, you must ask what legacy you wish to create. Einstein revealed that curiosity and knowledge are the cornerstones of understanding your place in the universe. In the end, what holds true importance are the connections you form, the love you share, and your unending search for truth. In this cosmic dance, every individual has a unique role, and each life is a brilliant flash against the vastness of time and space. The universe is a vast and enigmatic expanse that has captivated humanity since the dawn of time. But what is its real significance to you? Is it just an accumulation of stars, planets, and galaxies, or is there a deeper meaning to uncover? To explore this, it's vital to consider the vision of Albert Einstein, a man whose ideas fundamentally altered our perception of the cosmos and, by extension, ourselves. Einstein was not only a brilliant physicist, but also a profound philosopher of the universe. He showed us that time and space are not distinct, but are instead deeply interwoven in a cosmic ballet. This concept invites you to re-examine your own existence, to question the era you inhabit, and to consider how your choices reverberate throughout the cosmos. You might often feel small when faced with the boundless night sky and wonder about your life's influence on such a grand scale. However, viewed through Einstein's perspective, you can see yourself as an integral part of this massive network. From the atoms that constitute your body to the stars that shine at night, all things are connected. The very elements within your cells were forged in the hearts of stars, meaning that when you look up, you are in a very real way witnessing your own origins. Einstein's legacy also pushes you to contemplate the nature of knowledge itself. He spent his life challenging the conventional wisdom of his time, teaching us that curiosity is the very engine of scientific advancement. Sometimes the most profound answers are the simplest ones. So why do you so often settle for what is already known, instead of continuing to ask questions? The pursuit of knowledge is a limitless voyage, and every question asked brings you another step closer to the truth. But what are you to make of the uncertainty that clouds your place in the universe? Einstein demonstrated that we don't always get definitive answers. The theory of relativity, for example, taught us that your perception of time and space can change depending on your circumstances. This idea encourages you to embrace ambiguity and to recognize that the universe is, ultimately, a realm filled with mysteries yet to be solved. Einstein's vision also prompts you to question your relationship with time. In a world that seems to move at a relentless pace, his insights serve as a reminder that time is relative. It is not merely a clock that measures passing seconds, but an experience that shifts with your perception. Moments of joy can feel fleeting, while hours spent waiting can seem to stretch on forever. This forces you to ask, what does time truly mean for you? As you explore the universe, you also face the sheer complexity of existence. Einstein taught us that there are invisible forces, like gravity and dark energy, that sculpt the very structure of the cosmos. These forces remind you that even though you cannot always see them, they have a profound effect on your life. This naturally leads you to ponder what unseen forces might be shaping your own journey. Finally, Einstein's philosophy beckons you to reflect on the future. As science progresses, new questions and challenges continuously emerge, guaranteeing that our collective exploration of the cosmos is a journey without an end. Consider the multiverse theory, which challenges you to contemplate the existence of realities separate from your own. If this is true, It fundamentally alters how you perceive your identity and define your goals. This raises a profound question. Are you alone in this immense cosmos, or are you simply a single thread in a much larger tapestry of existence? Undoubtedly, Einstein's influence extends far beyond the realm of physics. His life's work is a powerful inspiration for you to continually pose questions, to persistently explore, and to never cease in your pursuit of learning. The real challenge is to integrate this spirit of relentless curiosity into your own life. It is crucial to accept that, even with our remarkable progress in understanding the cosmos, a vast expanse of mystery remains uncharted. Einstein showed us how to embrace this ambiguity, to appreciate the enigma, and to find elegance in the unknown. After all, curiosity is the catalyst that can ignite the flame of knowledge anytime, anywhere. In an era overflowing with information, it's vital to step back and ponder life's great questions, like what it means to be human in such a boundless universe. Albert Einstein's life reminds you that while your individual days may seem trivial on a cosmic scale, each of you possesses the capacity to significantly affect the world around you. Your curiosity, your passion, and your desire for comprehension are the very instruments that empower you to explore not just the universe, but your own being as well. In the final analysis, this shared quest for understanding is what unites everyone on the magnificent and expansive adventure that we call life.